Hello and welcome back. Alright, so in today's video we're going to take a look at another sorting algorithm, and this one is called selection sort. Alright, so now the interesting thing about today's selection sort is that the performance characteristics that we're going to take a look at for this particular implementation that we're going to do in this video is actually going to be pretty much the same as bubble sort. Both are going to be really bad when you search, when you sort an array of integers. So the interesting thing about selection sort is that if we used a different underlying data structure besides an array, we can actually turn selection sort into a really good a really good selection algorithm. And we'll actually take a look at that in a later video when we start talking about some of the different data structures that we're going to need in order to implement that sort. But for this video, we're going to go ahead and do the basics of just what selection sort is and how we go about implementing it. Okay, so let's go ahead and start off with our array again so we can talk about what the strategy is for selection sort. All right, let's erase that little tail off of our array. Okay, so let's just have, we don't need to fill in the values. Okay, so we have some array, and the idea behind selection sort is that we actually, our first time through, we always start at the beginning here, and we start at this item, and then the goal is to find the minimum value within this space. And once we do that, we compare that value with the current index that we're on, and if it is a smaller number, then we swap them. Or if the index value that we're at is greater than the minimum item that we found, then we swap those values. So it's basically bubble sort in reverse. Where bubble sort, remember, we push the biggest number to the top. Well, in selection sort, we're actually pulling the smallest one all the way down to the front of the array. All right, so let's go ahead and set up our function prototype for this. So we're going to have void selection sort, and we need an int array. Use a little different syntax for you this time, and the size of the array that we're going to be working with. Okay, so the only thing that we really need for a setup value is, remember I talked about we're going to need this minimum index value. We'll need that, and we're going to need two for loops, right? We're going to need the one for loop that goes through all of these items, and then we're going to need the for loop that finds the minimum for the current item that we're looking at. So let's go ahead and get started with that. So here's our outer loop for int I equals 0, I is less than n minus 1, I plus plus. So why are we doing n minus 1 instead of going all the way to the end of the array? Well, remember the goal is to find the start at an index and then find the minimum in the remaining set of the array. So we need n minus 1 so that we always have a remaining set of the array. Otherwise our algorithm breaks down at the last value. Okay, and so now we're going to need that minimum index guy. So int min index, and this value always equals, or starts at I. It always starts at the index that we're looking at to compare. Okay, so now we need another for loop, int j, and this is going to equal our index value plus 1. So I plus 1. Okay, and what we're going to do is go to the end of the array. So this is while j is less than n, and we do j plus plus. Okay, so what do we want to do? We want to find the minimum value within this subset of the array. All right, so we know that we're starting here with j, and we want to find the minimum value. Well, we know that the minimum value is going to be started off at this guy, so we know we're at least going to have a valid comparison. So if array of j is less than the array of the value at min index, Then we set min index equal to j. That means that the value that we found is smaller than whatever our current minimum is. And if that is the case, then we know that we want to swap the values between the min index and the current location at I. Perfect. Okay. So now, inside of our for loop, this is executed all the way to the end for j, so we're good to go. All right, so now what we need to do is we need to say, hey, that min index, do you equal I? Because if the min index still equals I, that means there was no swap to be made. Okay, so if min index equals, let's do not equals I, then we need to do our little temp variable, and temp equals array of I. Our array value at min index, at I equals the array min index and array min index equals temp. Okay, and that, my friends, is a selection sort. So let's go ahead and test this out with a small array. Okay, let's have a 4-element array, and we'll see if I have made any mistakes on this implementation. So 2, 1, 3, 4. Okay, so we know that n is going to be passed in as 4. Sorry, I was doing a zero-based counting there. N is going to be 4. All right, so our first time through the array, let's just draw a little line. This is our input that's coming in. All right, so our first time through the array, I is going to be 0, or initialized to 0. We're going to loop until n is less than 3. So we're going to go from the values of 0 through 2. Our min index is going to be I the first time. Okay, so let's look and see what's going on at this first loop. So let's go ahead and draw our array so I can draw our little pointers of what's going on. All right, so we have 2, 1, 3, 4. Our first time through our loop, I is pointing at this guy. Okay, so our min index has been initialized to I. So we're doing our j loop, so we're going to ask the question, does the array value at j starts here, is the array value at j less than the minimum index? Why, yes. Yes, it is, because min index is I. So 1 is indeed less than 2. So we're going to change our min index, which was pointing to I, to point to j. Okay? You probably can't see that. Min index now is going to equal j. So at this point through the array, or this loop, our first iteration through, min index has been updated to j, which we'll just mark as 1. Okay, so now our second, we're still inside this loop right here. Our j is going to move over to here, and we're going to ask the same question. Does the array value at 2, which is 3, is that less than our min index? And remember, our min index is 1. 3 is not less than 1, so we don't change min index. And then j is going to go here, and we're going to ask the same question. Is 4 less than 1? No, it is not. All right, perfect. So now we break out of this for loop because this criteria has been met. J is indeed now equal to n at this point through our loop. And now we ask the question, hey, does min index equal I? That is, does the min index actually point to the value that we started looking at. If that's the case, that means that's actually the smallest number. That is not the case this time through our loop. So what we need to do is we need to swap 1 and or the value at index 0, which is I, with the value at the min index, which is 1. All right, so we need to swap the values 1 and 2, right? And so we store we store the value of 2 in temp, and then at the location where 2 is, we store 1, and then where 1 used to be, we put 2. All right, so our new array looks like this through our first iteration of this loop. 1, 2, 3, 4. Okay, so now we go through n. Guess what? N still equals 4. We're not doing any decrementing of n like we did with bubble sort. N equals 4, but I now equals 1. All right, so now 1 is in a good spot right here. This value of 1 is in a good spot. I is going to start here, and we're going to do this same loop again. All right, so we jump through here. Min index gets initialized to I based on this loop. All right, so j is going to start at 3. Well, the value of 3, it's going to start at index 2. 0, 1, 2, 3. Remember, zero-based counting. So j starts here. So we ask the question, hey, is 3 less than 2? No, it is not. Okay, so j goes over to 4. All right, we ask the question, hey, is 4 less than 2? No, it is not. All right, so guess what? Min index still equals I at this point. So when we ask the question down here, min index equals I, or does not equal I, this is false. It does equal it, so we don't need to swap any values. All right, so unlike bubble sort, where it actually terminates at this point because no swaps were made, selection sort keeps on trucking along. Okay, and the reason for that is 4 and 3 could actually still be out of order, right? Because we were doing a min index comparison on this 2 value all the way through. All right, so I is now going to be set to here. We have the values 1, 2, 3, 4 in our loop. N equals 4 still. I equals 2. Okay, so now I is starting here at 3. And so we ask the question for j, which starts at this point. That's real simple. 4 less than 3? No, it's not. We're done with this loop. N's 4. We now equal 4. Min index still equals I, so we don't do any swaps. So at the very end, we have our sorted array. 1, 2, 3, 4. And you can see that, we had to look at every item in this array twice. Well, more than twice. We had to look at all of these items each time through the array, and so our algorithm's complexity is basically n squared. This is actually a little bit worse than what we did with the bubble sort, because the bubble sort could have terminated a couple steps earlier. But that's selection sort, and we will be revisiting this algorithm when we talk about some other data structures, and we'll see how basically the same implementation of this sort, of this sort, will actually be a lot faster. All right, thanks.